We're now going to start section 7.1, where we will discuss fundamental identities and their uses. This section will focus on the relationship between our trigonometric functions and the algebra skills that we have learned in previous sections. It does this by focusing on an idea called a trigonometric identity. We will begin by reviewing the identities that we have already learned this semester. So we'll start with our reciprocal identities. Remember that these identities establish a reciprocal relationship between two of the 6 trig functions. For example, we know that the cosecant and the sine are reciprocals of each other. And so that is represented by these two statements here. We know that the secant and the cosine have a reciprocal relationship. And so we have these two identities to establish that relationship. And we know that the cotangent and the tangent are reciprocals of each other, and these final two identities establish that relationship. We also have the quotient identities, and we have 2 of those. Tangent is equal to sine over cosine, and then the reciprocal of that, which would be cotangent, is equal to cosine over sine. We have learned about the cofunction identities, which establishes a relationship between a pair of the trig functions when the angles are complementary. Remember that complementary angles add up to 90 degrees or pi over 2 radians. So remember that cosine and sine are cofunctions of each other, and that is what we have here on the top row. In other words, the cosine of one angle is going to equal the sine of the other as long as your angles add up to 90 degrees. We have a cofunction relationship between cosecant and secant, established by the second row. Again, the secant of one angle will equal the cosecant of the other as long as the angles add up to 90 degrees or pi over 2 radians. And we also have a cofunction relationship between cotangent and tangent, seen on the last row. We have identities that establish the period of each of the 6 trig functions. Remember that the period for the sine, the cosine, the cosecant, and the secant are all 2 pi, as we learned in the last couple of sections with the graphing. The period for the tangent and the cotangent function is pi. And so these identities simply establish the fact that as you move from one period to the next, the values will repeat. We have even-odd identities, which were established in our last section, but very lightly. And so we may need to talk just a minute about what these are. These identities give us a way to handle a negative angle inside a trig function. For example, if we have sine of negative pi over 3, because sine is an odd function, we are allowed to take this negative and pull it to the front and evaluate sine at pi over 3. And so we know that sine at pi over 3 is square root of 3 over 2. And then we have this negative that sits out in the front. And so that is the relationship for odd functions. Odd functions, the negative can be pulled out to the front of the trig function. We see that on the sine. We see that on the tangent. We see it on the cotangent and also on the cosecant. So these are all your odd functions, meaning that the negative comes to the front and we can evaluate it as a positive function and then put the negative on at the end. The other 2 functions are even functions. So that would be our cosine function and our secant function. And so what this means is that if we have a trig function like cosine pi over 6 and the negative is on the inside, that we can simply ignore the negative. And so that this would be equivalent to cosine pi over 6. And so since cosine pi over 6 is equal to square root of 3 over 2, then we know that cosine negative pi over 6 is also equal to that value. At the bottom, we have our Pythagorean identities. We will see that this identity, sine squared x plus cosine squared x is equal to 1, is an identity that is used very frequently as we start solving our trigonometric identities. We also have the other two, tangent squared plus 1 is equal to secant squared, and 1 plus cotangent squared is equal to cosecant squared. So with those in mind, let's go ahead and begin our first example. Our first example asks us to simplify the expression cosine plus sine times tangent. Now, one technique that we will learn and we will practice in this section is taking an expression and writing everything in terms of sines and cosines. So I'm going to begin by writing my expression down. And then what I need to do is I need to find an identity that can be used to substitute in for tangent so that the entire problem has nothing but sines and cosines. So I'm going to go back and I'm going to look for an identity that I can use for tangent. And I'm looking for something that only has sines and cosines in it. And so I'm looking specifically at this identity. Tangent is equal to sine over cosine. So I'm going to go back to my problem and I'm going to plug that identity in. So remember that tangent was equal to sine over cosine. So I'm about to substitute that in. I just wanted you to see that that is what we're going to do. We're going to place sine over cosine in place of that tangent. So as I do that, I'm going to rewrite. So I have the cosine stays the same, the sine stays the same, but when I get to this tangent, I'm going to substitute in sine over cosine. Now, once I make that substitution and everything is in terms of sines and cosines, I want to do whatever simplifying I can do. So this is where my algebra skills come in handy. I'm going to go ahead and multiply these two together. So a sine and a sine make a sine squared. I'm just multiplying those fractions. Right now, remember that this sine is over 1, so 1 times cosine is cosine on the bottom. Now, one other technique that we'll use quite often is finding a common denominator. Again, this is bringing in an algebra skill into our trig expression. So, if I want a common denominator, and right now this cosine is over 1 and the sine squared is over cosine, remember that it is common practice to use the product of the denominators. So we'll use 1 times cosine, which is cosine for our new denominator. Now, this fraction is no problem because it has the denominator that we want. This one, however, we need to work on. So what I'm going to do is I'm going to take this expression and I'm going to squeeze in and multiply by cosine on the bottom. And remember that if we do something to the bottom, we also need to do the same thing to the top. So essentially, I'm going to multiply that fraction by cosine over cosine. Okay, so let's look at what happens when we do that. Cosine times cosine becomes cosine squared. 1 times cosine is just cosine. And we're going to leave the second fraction alone. Not going to change that one at all. Now, since our fractions have the same denominator, we're going to put them together as one fraction. So this is going to become cosine squared plus sine squared, and I'm going to write it all over the denominator of cosine. Now, when I look at the numerator of this fraction, the top part of the fraction, the cosine squared plus sine squared looks familiar to me. Okay, remember that that is this identity, sine squared plus cosine squared, and we know that that's equal to 1. So I'm going to go back to my problem, and in place of sine squared plus cosine squared, I'm going to put a 1. And we'll leave the denominator as is. So now I have 1 over cosine. And again, I'm going to go back into my list of identities, and I'm going to find an identity equal to 1 over cosine. So we have this identity that can be used. So we can see that 1 over cosine is equal to secant. All right, so what we have just done is we've taken our original problem and we've simplified it down to secant. Okay, so let's look at one more. So this time we want to simplify the expression cotangent alpha plus sine alpha divided by the quantity 1 plus cosine alpha. Okay, so I'm going to start out the same way. I'm going to write my original problem down. I'm going to use the same techniques. So the first thing I'm going to do is try to find an identity that can be used for cotangent. I would like the entire problem to be written in terms of sines and cosines. So if I go back to here, we note this identity, that cotangent is equal to cosine over sine. So I'm going to go back to my problem and plug that in. So in place of this cotangent, I'm going to do cosine over sine. And the second fraction, I'm going to leave as is. Now remember our technique. If we're trying to combine fractions, we need a common denominator. The common denominator is most likely the product of your current denominators. So our new common denominator that we're shooting for is sine alpha times 1 plus cosine alpha. That is our two denominators multiplied together. So on my first set of my first fraction, I have the sine, but I need the 1 plus cosine alpha. So I'm going to multiply 1 plus cosine alpha for the bottom. And remember that if you do it on the bottom, you also need to do it on the top. For my second set of fractions, I have the 1 plus cosine, but I need the sine. And so I'm going to multiply top and bottom by sine. Okay, so let's look at what we have. I'm going to go ahead here on the top of this first set, and I'm going to distribute. So cosine times 1 is cosine. Cosine times cosine will be plus cosine squared. In my denominator, I'm not going to distribute. I can do it later if I decide I want to, but right now I'm just going to leave it like it is. My second set will be a sine times a sine, so that will be a sine squared. And then I'm going to write the same denominator, sine times 1 plus cosine alpha. Now, as we're working this, it's worth saying that your goal here is to show your steps. Your goal is so that someone who maybe is not that familiar with trig can follow from one step to the next. So the process is not to get to the simplified form, but the process is to show your steps getting to the simplified form. So once we have these two separate fractions that have the same denominator, we can push the fractions together and write them over one of the denominators. So I'm going to do that next. So I'm going to do cosine alpha plus cosine squared alpha plus sine squared alpha. And I'm going to put it over my new denominator. Now, note that we have right here, we have sine squared plus cosine squared, and we know that that's equal to 1. So my next step is going to be to go ahead and I'm going to leave my cosine as it is. And in place of this cosine squared plus sine squared, I'm going to put plus 1. Okay, so now we're looking at what we have, and we know that addition is commutative, in which case it doesn't really matter if it's cosine plus 1 or 1 plus cosine, that's the same. And so these are going to cancel, which leaves me on the top a 1 and a sine on the bottom. Now, if you remember that 1 over sine as a reciprocal identity, we can go back and take a quick look. 1 over sine is equal to cosecant. And so that will be our final answer on this problem. 1 over sine is equal to cosecant alpha.